All right, so 211 is called log functions. So we go back to talking about the comparison between the graphs of exponential and log functions, but now we're going to get a little bit more into detail on these, okay? So on the left-hand side, you've got two exponential functions, right? We've got growth and decay. If my b is greater than 1, this is the result of a growth model. So my graph looks like this. And if my b is in between 0 and 1, this is my decay model. So it looks like this, okay? Both of them have similar different qualities. So the intercepts for both of these, okay, for example, when you're looking at an exponential function, it would ask you for the y-intercept. And what's the y-intercept on both of those graphs? 0, 1. Good. Okay. Hello. Asymptote. So an exponential function will always have a horizontal asymptote, okay? And on both of these functions, the horizontal asymptote would be at y equals 0. Okay, now it gets a little bit different. So increasing on exponential or an exponential function, it is always increasing or is always decreasing. So let's go with the green one, where b is greater than 1. What's true about the increasing behavior? It's always increasing. So it'd be increasing from negative infinity to positive infinity. But the blue one is what? Is there any point on that blue curve where it's increasing? No. So it's always decreasing. Yep.
When you're talking about increasing and decreasing, you're talking about the x?
You're talking, no, the y. So you give the x values for the y values that are increasing. So I'm looking at the y values. Are the y values increasing? But then how I answer it, like on what interval is it increasing, I give the x values for the interval. Yep. So if this had said, let's say we go with the one that was green, which had exponential growth. If it had said increasing, I would put, or it would say on what interval is it increasing? Negative infinity to positive infinity. On what interval is it decreasing? Never. So it would be no answer. Okay, now the range. So range goes back to being the same for both of these. Or no, sorry, let's go to domain. Domain is the same for both of these, right? Is there a domain restriction on exponential? No, so domain is all real numbers. And then the range on these two would be from 0, not including it, to positive infinity. Then concave up and concave down are similar to increasing, decreasing. It is always either concave up or always concave down. It can't be both. So let's go back to the top. On the green function, or my b is greater than 0, so the exponential growth function, is that concave up or concave down? Up. And on the decreasing function, or on the exponential decay, what is it? Also concave up. So whether it's increasing or decreasing, it doesn't matter. It's the shape, obviously, that okay? They're both concave up. So both of these are up, okay? And then the end behavior. So we would use limit notation to describe the end behavior. I'm going to do this up here as well, okay? End behavior of your exponential growth, which is the green one. So the limit as x goes to negative infinity would be the left-hand side. The limit as x goes to positive infinity. What's the limit as x goes to negative infinity of the green one, my exponential growth? 0. It's going to 0. Good. And the right-hand behavior of the same model, it's going to infinity. Now let's look at your decay. What would be the limit notation for the left-hand behavior? So as x goes to negative infinity, f of x is going where? The blue graph, or the decay. It's going to infinity, good. And as it goes to positive infinity, 0, good. So they're the reverse. Okay, so hopefully that was nothing new there. That was like all review. Now let's talk about your log function, okay? Your log function, so the parent function of log looks like this. It's like a square root that doesn't have an end. So it's a square root that would continue to point down to negative infinity. Okay, and it would have a vertical asymptote. We don't see it, but it would have a vertical asymptote on the x-axis. So for for a log, it's going to ask you for the x-intercept, not the y. And it is 1, 0. This is, again, just the parent function. The asymptote would be a vertical asymptote, and it is at x equals 0. Is this log, or on what interval is this log increasing? The entire thing. But how do we describe this entire thing? What's the smallest your x values can be? Well, and it can't even be 0, right? So 0 with a parentheses to positive infinity. There is no part of this that is decreasing. Yep.
There's no horizontal asymptote.
There is no horizontal. There's a vertical. Yep.
By increasing x value.
The y values are increasing, but you give the x values for where they are increasing. So when we describe the interval, we give the x values. But to actually look at the behavior, we're looking at the y's on this whole thing. So the y's are going to keep getting bigger and bigger and bigger and bigger. Does that make sense?
Yeah.
Okay. All right, how about domain? What would be the domain of this log function? 0 to infinity. Does not include 0. What's the range? Good. Concave up or concave down? Down. And as the limit, when we go to describe the end behavior of this graph, I'm just going to do it up here so that we can see it a little bit better. The left-hand behavior of this graph stops at this vertical asymptote. So I would say the limit as x goes to 0. And what side are we coming at 0 from, the right or the left? From the right of my graph, right? As it's coming from the right towards 0, which means I would write the end behavior like that. The limit as x goes to 0 from the left. Now what's happening to the y values? So as it's coming in this direction, what's happening to those y values? They're going to negative infinity. Now the right-hand side of this graph does not have a restriction. It's going to keep going on to positive infinity. And what's happening to these y values? They're going to infinity. So if you have a vertical asymptote, this graph is never going to go to negative infinity, okay? If it's to the right of the vertical asymptote. So we say the left-hand side of this is going towards the asymptote from the right, and that's how we describe it.
So for the limit notation for the logs, we always put,
One side of them is always going to be the vertical asymptote.
so like where you always put for one of them, like limitation x to 0.
So you're going to see our vertical asymptote will move. But on one of the, and it's also going to depend on what side of the graph my log is. One of the end behaviors, one of them is going to infinity or negative infinity. The other one is going to the vertical asymptote. And they might come from the right or they might come from the left. So we're going to manipulate these a little bit. But one of them will always be a number. Is that what you're asking?
Yeah.
Yeah, okay. One's always going to be infinity or negative infinity. One's always going to be a number. And that number is going to be your vertical asymptote. All right, questions so far? So this is just the parent function of log. So one thing you want to know is, what does the parent function of any log look like? Obviously, the base is going to change. We're going to shift these left, right, up, down, stretch, all the things that we've been doing to all the other functions. But for the parent function, it has all of those characteristics. All right, so there are two methods to graphing logs. The first is to find the exponential inverse. So like if it's log base 2 of x, its inverse is 2 to the x. Then find the graph of that by plugging in using like a t-chart, but then you have to switch your x and y's. So that is one way, and if it is just a simple log like log base 2 of x, that is not a bad option. If there is any sort of translation or stretch on it, then I would recommend method 2, which is converting your log into exponential form, and then you plug into the y instead of the x. And then we don't have to do any switching. So I'll show you what I mean. If it says f of x equals 2 to the x, if it said f of x equals log base 2 of x, then one option, method 1, is make that 2 to the x, plug in for my x values, -1, 0, and 1. I'd get a half, I'd get 1, I'd get 2. But then to graph it, I have to switch my x and y's, which would make it go back to the log. So I switch it to the exponential function, figure out the points, but then I have to switch it back to the log function. That's one option. That's method 1. Method 2 is take my log, replace the f of x with a y, and convert this. So I'm not making it its inverse. I'm converting it into exponential form. So the 2 picks up the y. And then instead of plugging in for the x, we plug in for the y. So if y is -1, then this is a half. If y is 0, this is 1. If y is 1, this is 2. And then we graph this without having to switch it back. So if I'm going to pick between them, I typically pick method 2, especially because as soon as you start to make a vertical shift or even a horizontal shift, people mess up the conversion into its inverse. Yeah. You end up with the same graph, but it's a different method. It's literally making it its inverse. So you switch the x and the y, and then you have to switch it back at the end. This one is not switching the x and y, it's converting it to exponential, so I didn't change the equation, just the format it's written in, and then plug in for y. So two different, if you're going to do the first, you got to make it its inverse, and then you have to switch the x and y at the end. Yeah. Scarlett.
Oh, sorry. Yeah, I know you said method 2 is probably better if there's like a stretch or something.
Yeah.
What about method 1, like if it's just nothing? Like what would method 1
So if it's just like a log base 2 of x, that's not so bad. Because you already know how to get to its inverse. You don't have to really like switch them, solve for the new one, figure it out, right? But if not, I would recommend method 2. Yeah.
So you recommend method 2. When we did method 1, we put in the exponential and we switch it back at the end?
You have to switch your x and y's at the end.
Okay.
Yeah. All right. All the same translations and dilations that we've been doing the entire year carry over for for logs. So a vertical translation is going to happen after. So if there's parentheses, it happens outside the parentheses. It's positive, it shifts up. It's negative, it shifts down. A horizontal translation happens inside the parentheses, okay, just like always. And this is going to move your vertical asymptote. A horizontal translation shifts your vertical asymptote. So if I want to find the vertical asymptote, I just simply set my equation, whatever's inside the parentheses, equal to 0, and that's going to give you your vertical asymptote. If the negative's on the front, it flips it upside down. So if my parent function looks like this, then a reflection with a negative on the front is going to look like this. And a reflection inside the parentheses flips it over the y-axis so it points it left. The vertical stretch and shrink happens just like you would normally say. If there's a number on the front greater than 1, it's a vertical stretch or dilation by a factor of that number. By a factor of c, okay? If it's in between 0 and a half, it's a vertical dilation. Same thing by a factor of c, but it would be a vertical shrink. And then if the number is inside the parentheses, now it's a horizontal dilation by a factor of 1 over c. So if it said 2x on the inside, then it's going to be a factor of 1 over 2, which means it's going to horizontally shrink it. It's going to make it more condensed as if the walls were caving in. Okay, so think about what else impacts things like your domain and your range. Your range is going to be all real numbers for these logs. If I'm looking at a reflection, let's say, and there's a negative inside, that's going to change your range, right? The range on this guy becomes negative infinity to 0. And then we go back a ways, but we talked about this too. If there is a reflection on the inside and a horizontal shift, So if it says log base 2 of x, well, negative x plus 1, for example, there's two ways to look at that. This flips it left, so it's going to point it left. And this would typically move in which direction? It would move it left, but then I'm going to flip it over the y-axis, which means it actually moves it to the right. If that confuses you, then take the negative out and look at them as two separate translations. This is going to be a reflect over the y-axis, so it's going to point it left. And this is going to be a shift to the right one.
That one now. Oh no, it's reflection.
It's a reflection. Yep. Yeah.
You said like when you were showing the reflection one, you said the main bit is 0. How is that?
This one. Not the range. Did I say range? I did. I mean domain. Sorry. Domain is all, range is all real numbers. Domain is what's restricted here. Yes.
Wasn't that like, if it's like stuck with the horizontal, we have to stretch before moving or something?
Yeah. So same order is if it's horizontal, we move then stretch. If it's vertical, we stretch then move. Yep.
For the stretching and shrinking by factor, it's 1 over c, right?
For horizontal.
Yeah, but if that's negative 1,
But not the negative is a separate a separate translation than the 1.
Okay.
The 1 is leave it alone, stretch shrink, right? Because it's just 1.
Yeah, but isn't it 1 over 2 now?
No, it'd be 1 over 1.
Oh.
Yeah.
Oh, okay.
The negative would be the reflection. And the good thing is, I mean, yes, we can use these for translations, but we also could just plot some points and we could graph these. So we're going to do both methods on this one. You only have to pick one, okay? So the first method, and so I want to be really clear, I'm doing both methods, two separate ones. You could pick which one. You don't have to do both. But I'm going to do method 1 here, which the first one is we find the inverse of this function. So to find the inverse of the function, I'm going to make it y equals log base 4x minus 5. And then switch the x and y because we're finding the inverse. And now we want to solve for the new y. So the 4 is going to pick up the x. And then I'm going to add the 5. Oop, this is y. And so f negative 1 of x equals 4 to the x plus 5. So that whole process is finding the inverse. Then we have to plug in. So this is really the inverse if you want to remind yourself. I'm going to plug in for x. So I'd get 4 to the negative 1 plus 5, 4 to the 0 plus 5, and 4 to the first plus 5. So I get 1/4 plus 5, which is 5 and 1/4. I get 1 plus 5, which is 6. And I get 4 plus 5, which is 9. So find the inverse, plug in for x, and then before I can graph this, I have to switch it back. So the y's become the x, and the x become the y's. So then I would go to the graph. I would plot 5 and 1/4, negative 1, 6, 0, 9, 1. I would find the vertical asymptote from the very beginning by setting my parentheses equal to 0, and I'd get a vertical asymptote at x equals 5. And now I know my graph looks like this. With me so far? So again, that's method 1. Find the inverse, plug in for x, switch your coordinate points back. Method 2 is take my function and put it into exponential form. So y equals log base 4x minus 5. 4 picks up the y. 4 to the y equals x minus 5. 4 to the y plus 5 equals x. And on this method, instead of plugging in for the x, we're plugging in for the y. So 4 to the negative 1 plus 5, 4 to the 0 plus 5, 4 to the first plus 5. And I get the same 3 coordinate points. I'll go back to it because I'm going to do it again for this one. So then this time I don't have to swap them back. These are the points I plot. 5 and 1/4 1, or sorry, 5 and 1/4 negative 1, 6 0, and 9 1. I'm going to get the vertical asymptote the same way for both of them, which is go to the original function and set the parentheses equal to 0. Because that's your horizontal shift, so it's going to move your vertical asymptote. So it's at x equals 5. So you choose. I'm not going to do both methods every time. I typically choose method 2. But you get to choose which one you want to do. All right, it also asks for domain. What's the domain of this function? Good. 5 with a parentheses on the 5 to positive infinity. The x-intercept we could get from the middle point on our t-chart in both cases after I flipped it, or like the one on the right after I flipped it. The one on the left, just the middle. Or I could go to my graph. That's 6 0. And then we already found the vertical asymptote, x equals 5. Yeah.
So method 1 is a necessity for flip, but method 2 we don't have to flip.
Correct. Right. Because method 1, we make it its inverse. So we switch the x and y to solve for it from the beginning, which means you have to switch the x and y back. With method 2, we don't switch the x and y. We just convert it to exponential. That's not changing your variables. All right, let's do limit notation. So the limit notation on the left-hand side of this graph, are my x values going to negative infinity? They never make it, right? Where do they stop? At 5. So as I'm coming to 5 from the right, what are my y values doing? They're going to negative infinity. And as I'm going to the right-hand side of this graph, do my x values make it to infinity? Yes. And what are the y values doing? Also going to positive infinity. Good. So it could ask you any part of this. It could ask you to graph it. It could ask you just for the intercept, just for the domain, just for the end behavior. Like there are practice questions on the AP exam when we got to, like in May, that it asks you for the end behavior, and in order to understand that, you had to graph it. So it might not say graph and find the end behavior. You might need to know what it looks like, and that could require you to graph it. All right, one more. You do this one, and then we're going to switch to use our translations. All right, so this is method 2. I converted it to exponential, but again, you have to move the 1 before I can get to the log. So anything that's happening on the outside of the log, you have to do to the y before you switch it. So like let's say there was a vertical stretch. If there was a 2 on the front, I'd divide both sides by 2 before I convert to exponential. If there was a negative on the front, I'd divide both sides or multiply both sides by negative 1 before I convert to exponential. Then it becomes 4 to the y plus 1 equals x plus 2, subtract the 2. So then I plugged in for y and I got these points. -1, -1, 2, 0, 14, 1. I got my vertical asymptote from the parentheses. So if x plus 2 equals 0, then x equals -2. That's where my vertical asymptote is. You've got to know to curve, just like an exponential, you've got to know to curve up. You've got to know to curve a log down. So even if you don't have points in here, you could obviously plot like point here, which wouldn't be enjoyable, but you could do it. But you got to know to hook it and point it down, okay? So my domain is what? Good, and it's a parentheses on the -2. My x-intercept I can get from my chart or from my graph, 2, 0. Vertical asymptote we got here, x equals -2. So the left-hand behavior this time is again restricted, right? It never makes it to negative infinity. So x goes to -2, to -2 from the right. As that's happening, my y values are going to negative infinity. And then as my x values are going to positive infinity, my y values are going to positive infinity. How'd you do? Good? Okay, yeah.
So the 2 plus, I don't get the 2 plus still.
The 2 plus.
The 2 plus.
Oh, so if I want to know end behavior, I'm going right, left, right? So the left-hand behavior of this gets stopped. It never makes it. It gets stopped where the vertical asymptote is. So now I've got to describe as I'm going towards that asymptote, where are the values? They're on the right-hand side of it. So as I'm going towards it, it's coming from the right, which means it's coming on the plus side.
Okay.
Does that make sense? Okay. You're welcome. All right, now let's talk about, without having to graph these full out, what do these look like and how do I get to the answers for domain, range, asymptotes, and end behaviors? So if I look at A, right, tell me what's happening to my graph in terms of the translations. What's the negative on the front do? The negative part. The 2, yes, but the negative part does what? It's going where? Over the x-axis. So it's taking my curve that normally goes like this and it's flipping it so it goes upside down. So it goes like that, okay? The 2 is a vertical stretch, or dilation by a factor of. Good. What does that do to the actual graph itself? Stretches it this way, right? It would make it taller, okay? And then the x minus 3 inside the parentheses. What's the minus 3 inside doing? Moves it to the right 3. Okay. So if I was to just use translations on this to get an estimate of what this graph looks like, 1, where's my vertical asymptote? X equals 3. So 1, 2, 3. That's one of the questions. Asymptotes, it would be the vertical asymptote at x equals 3. There's no horizontal asymptote. Okay. This is going to be flipped upside down, shifted to the right 3, which makes sense because it's going to be to the right of my vertical asymptote. Okay. And it's vertically stretched. So it's going to look something like this. Okay. This would be a vertical stretch. And everything got shifted to the right. My vertical asymptote went to the right 3. This is going to come after that, okay? And it was upside down. So all of those things are an estimate of what my graph looks like. But it's enough information for me to get what I need to get. What's the domain? From 3. Good. 3 to positive infinity. What's the range? Every log. All real numbers. We got the vertical asymptote. There's no horizontal asymptote. End behavior. So as my limit, or at the limit of the graph, as x is coming to the left, it would be to 3 from the right. What's happening to your f of x values? Going to positive infinity. Limit as x goes to infinity. F of x is going negative infinity. So we can do all of that. Where did it go? Okay, so now think about B, okay? B says ln. We had this conversation last week. Ln is really what? Log base E. So it's just a log. Notice I never once used the base on the log base 3 because I'm not getting exact points other than my vertical asymptote. Okay, and that has nothing to do with the base. So the same here. It doesn't really matter what log this is. Okay, but log base E is 2.7. It's an approximation, which means this graph would actually be very similar to log base 3. Okay. But I don't even need that information. I need to know what's happening with my translations. So inside the parentheses now is 4 minus x. So what's happening there? It's negative x plus 4 technically. And if you need to see it that way, switch it. Because those are 2 different things, right? Negative x plus 4 could be written like this. And I'd have to know that the negative is doing what? It flips literally the shape of it from right to left. It flips it over the y-axis. So I either have to move it left and then flip it. So if I did that, it would be a move left. And then it would be a flip over the y-axis, so it actually moves it back to the right. Does that make sense? Or I take the negative off of it. I say this is log base E of negative x minus 4. And I treat them as 2 separate things. This negative literally just switches it from left to right direction, not a full over the y. So it's going to point my log to the left. And this is a reflection to the right. I'm going to shift to the right. Either way, my vertical asymptote, because if I set this equal to 0, or I set this equal to 0, or I set this equal to 0, in all of those cases, the vertical asymptote is still at x equals 4. This is a shift up 3, so I'm going to point it left, so it's like this. But I'm going to lift it up a little bit higher because it would typically be shifted up 3. That's all. Okay? Yeah.
Isn't it like minus 4 because it's plus 1?
This is left 4, but then reflected over the y-axis. So if I keep them together, I'm going to go left 4, but then I'm going to flip it over the y-axis, which moves it to the right at the end. If you pull it off of it, there are 2 separate ones. This is a reflection over the y-axis. It's still how I describe it, but really it just flips the direction of the shape. And this moves it to the right 4. So you could look at it either way. All right, so does my vertical shift up impact my domain? No, right? It would impact range, but range is all real numbers, so it really doesn't change anything, okay? So my domain goes negative infinity to my vertical asymptote, which is at 4. My range is all real numbers. I have a vertical asymptote at x equals 4. And the limit as x approaches this time, my graph is coming from the left and it's being stopped on the right. So as it's going to 4 from the left, my f of x is going to negative infinity. And it never makes it all the way right, but it does go all the way left, which means x goes to negative infinity. F of x goes to positive infinity. So in these cases, I'm simply using my translations to figure out the direction and the overall shape. You good so far? Okay. So it says write the log function with the given information. So this could have multiple answers, okay? We know nothing about like the base on these logs, so we tend to just make it log, okay? But what we do know is that there's some sort of specific information given. In A, they give you the end behavior. So in A, it says, as x goes to positive infinity, y goes to positive infinity. So that tells me that the right-hand side of my graph is not bounded, right? The left-hand side says, as it's going to negative 4 from the right, my f of x is going to negative infinity. So what does that tell you is happening at negative 4? There's a vertical asymptote there. And it's going to negative infinity, which confirms the overall shape of this log. So I'm going to make it whatever base I want. I'm going to make it log, just so it's log base 10. And how would I write it so that it has a vertical asymptote at negative 4? Good. I'm not worried about a stretch at all. I'm not worried about a translation. Well, I can't make it negative. It would flip it upside down. All right, B says domain is negative infinity to 6. So what does that tell you? There's a vertical asymptote at 6. Okay, what side of the graph is my log on? The left side of that or the right side? The left side, because it's going from negative infinity to 6, right? What I don't know is if it looks like this or if it looks like this. So there's more than one answer to these, okay? What I have to know is that inside the parentheses has to be x minus 6. There obviously has to be a log involved. But let's say you chose this curve. What kind of translation happened there to go from my parent to that? It's upside down, right? If it's upside down, there's a negative in the front. So that could be an answer. F of x equals
The normal log one works too, right?
the normal log. Well, it has to get flipped because it has to curve. So I have to flip it in some way, right? Because a normal log would point it towards here. So I had to flip it. This is a flip that I could do, which is just upside down. This is what kind of flip? This is over the y-axis, right? What causes a flip over the y-axis?
Negative on the
A negative on the x. So if I'm going to do that, and I put it like this, what has to happen after that to get my translation to go to the right?
negative.
It actually has to be, if it's a negative x, let's think about it. If it's a negative x, right? This goes which direction? To the right. And then this, so this would be like this. And then this would flip it over the y, so it flips it this.
Negative is x plus 6.
Right. Wait, sorry, I just did that wrong. No. So if it's like this, that's what's going to happen. It would flip it this way, or no, it would shift it to the right, but the negative is going to flip it back this way, which matches what we did. So this is fine.
So the vertical asymptote still at, see,
Correct. But if I do this, what does that do?
then it changes.
So the only thing this does is it shifts it to the right, 1, 2, 3, 4, 5, 6, but it doesn't flip it over the Y. It literally just changes it to point left to right. So this would actually be here. So this does not work. This does. Okay? If you're going to take the negative out, then it has to be plus 6 on the inside. So this, when the negative is separate, this would go left 6 and then flip so that it points the other direction. So these are both the same graphs. Okay. So watch the negatives on when there's a negative and there's a horizontal translation.
Will you make us draw a graph on the test?
Yeah.
So if it is
Quick.
going to be valid, the answer.
She said, is there, sorry to disappoint. Is there a graph on your test? Yes.
What if they're both negative?
If they're both negative, are there parentheses or not?
The outside and the inside.
Okay, so negative, log, negative.
It's not.
Oh, that's really helpful. Are you saying with or without parentheses on the inside? So, hold. This is a reflection over the x-axis. So it takes my log that normally goes like this and it points it down, right? What's the negative on the outside of the parentheses on the inside? Do
Over the Y.
over y. So it's going to now point this guy left. And the minus 6 on the inside. Right 6. Because we took the negative out. If the negative was in, it would have been left 6. Does that make sense? And then reflected over the y. If you distribute in, you got a negative and a positive. This changes the direction of that. So either way, it goes the other, right? So this goes to the right. This would have a vertical asymptote. And then it would point it like that. So now it says sketch a graph of the transformation of f of x equals log base 2 of x. So it's actually giving you what the parent function looks like, okay? Which is a vertical asymptote at 0. It's shifted to the right. There are certain coordinate points that we can use, which are 1, 0, and 2, 1. Actually, all right, so if I go to A, what's the 2 on the front do? Vertical dilation by a factor of 2. What does that mean on my graph? I'm going to take all those y's, stretch them vertically, right? I'm going to take my y's, I'm going to multiply by 2. Then the minus 3 on the inside causes what? To the right 3. Does order matter? No, because one's a vertical and one's a horizontal. If they are both vertical or they are both horizontal, now order matters. Does that make sense? Okay. So I can either shift my graph to the right 3 places. So I'm going to go to the right. 1, 2, 3. 1, 2, 3. My vertical asymptote shifts to the right 3. So it looks like this. And then I could multiply by 2 for the y's. So my 0 stays, but this gets a little bit taller.
Does that have to be like exact coordinate point?
No. Questions on that one? All right, now go to B. What's the negative on the front do?
Reflection over the X.
Over the X, which really just means flip me upside down, right? What's the plus 1 inside? Left 1. What's the minus 4? Down 4. Now, what do I do first, the stretch or the move? Because it's vertical, right? The stretch, which means really flip it upside down first. So I could take my y values, multiply by negative 1, or I could flip it upside down. So it looks like this. Then I would shift it down 4 places. 1, 2, 3, 4. 1, 2, 3, 4. And now I'm here. And the last thing I'm going to do is shift everything to the left 1. That means my vertical asymptote also shifts left 1. We did the negative y first, but you could have also shifted it down and then done that. Because it's not a stretch, it's just a reflection. Still good? Okay, last one. Now it's 4 minus x inside. So what do we have to do?
Subtract 4 and then change the sign.
So I could do negative 4 like this, right? I could do that. Which means I can move to the left 4, flip it over the y-axis, or I can move it to the right 4, point it left, same thing. Either way, I've got, now my vertical asymptote is at 4. So shift it to the right, 1, 2, 3, 4, point it left. Oops. And the first thing I have is this. And then up 2. Questions?
What does the little 2 mean?
The little 2 is just the base. So if I was to plug in actual points, it would affect, but it's not. That's what got me the parent function to begin with. So they said this was f base 2 of x.
But it doesn't affect the domain range.
No. Think about what affects domain, a shift left, right? Or a reflection. Okay.